Hey everybody, this is Alex Debris. Today we're going to learn some DynamoDB. This is a little different than some of the DynamoDB work I usually do, which is more focused on data modeling, advanced data modeling, things like that. We're not going to really dive into that today. This is going to be more about some practical aspects of Dynamo, how to use the DynamoDB API and work with your items in Dynamo. So if you want to know more about data modeling, check out some of my other content, but if you want to learn how to use the API, this is a great one for you. So this is the DynamoDB workshop. This is part one, which is going to be focused on basic operations. 5 things I want to be talking about in this workshop here. First of all, we're going to start off with creating a table. How do you create a table in DynamoDB? What do you need to specify? Second, we're going to write some data into our table using the put item operation. Third, we'll read that data back using the get item operation. Fourth, we'll prevent overwrites on existing data using condition expressions. And then finally, we'll delete that DynamoDB table. As I mentioned, this is part of a DynamoDB workshop. It's actually a 3-part workshop. So this is the basic operations part. So this video, that's what we're going to focus on here. But there are 2 other parts. Second part is about the composite primary key. How do you use that composite primary key? Use the query operation to fetch multiple items in a single request. And the third one is about handling additional access patterns using secondary indexes. Really powerful tool in DynamoDB. If you want to do self-guided or follow along here, you can check out the repo associated with this workshop. That's at Alex Debris. That's on my GitHub, Alex Debris DynamoDB workshop. So let's get started here. And the first task we're going to do here is start off by creating a DynamoDB table. Now, before we get into that, I do want to talk about a little bit of DynamoDB terminology just so we're on the same page. So 4 basic terms I want to cover here: table, item, primary key, and attribute. We'll do this by way of an example that we'll be using throughout this workshop. So imagine we have some data in our application that stores information about users. I have a few sample users here, 3 records, myself, Alex Debris, and a few famous folks, Brad Pitt, Serena Williams as well. If you look at all these records together as a whole, that's going to be called a table. So all the records together, that's going to be a table, similar to a table in a relational database or a collection in MongoDB, with some differences as well. Now, if you want to look at an individual record, that's going to be called an item. So I've outlined here that Alex Debris item that has a name, interest, address, all that stuff. That's going to be an individual item, similar to a row in a relational database or a document in MongoDB. Now, when you create that DynamoDB table, you're going to need to specify what's called a primary key on your table, and every item that you write into that table needs that primary key, and you need to uniquely identify every item in that table by that primary key. So in this situation here, you can see on the far left, I have a primary key. It has this partition key of username, and I have Alex Debris, Big Time Brad, the Serena, right? Each of those are uniquely identifying each user in our table. In addition to that primary key, we also have attributes on our data here. You can see name, interest, address, similar to columns in a relational database. The big difference here is you don't need to declare attributes up front on your table like you would in a relational database. So DynamoDB is schemaless. You don't have to declare all those different attributes. You can just do that as you go here. So those are the big things you need to know about DynamoDB. Let's get into creating a table with DynamoDB. A couple things that you need to know when you're creating that table. Number one, you have to declare that primary key. Remember I said DynamoDB is schemaless, but every table requires that primary key. Every item you put in that table requires that primary key. So we're going to declare that when we create our table. The second thing you need to do when you create this table is configure your DynamoDB billing settings. And let's walk through how DynamoDB billing works really quickly here. Basically, DynamoDB, you're going to pay for reads and writes directly rather than resources. And this is different than how a traditional relational database works, or even, MongoDB, something like that. Any instance-based databases, for those you're paying for resources, right? You're paying for CPU, you're paying for RAM, you're paying for IOPS or networks, things like that. And that can be difficult to sort of estimate how much actual resources you need, right? Even if you have a good sense of how many requests you're going to make, it's hard to know how that translates into CPU or RAM, or knowing what that bottleneck is. With DynamoDB, it's different. You're going to pay for reads and writes directly through things that are called RCUs and WCUs. So RCU, read capacity unit, WC, write capacity unit. That basically gives you some amount of reads per second on your DynamoDB table. So you can provision in advance, say, hey, I'm going to need this many reads of this big a size, and Dynamo is going to give you that ability on your table. Now, one thing that's really interesting is that in addition to provisioning that capacity up front, you can also use an on-demand or pay-per-use mode. So DynamoDB has this provision capacity mode where you can say, hey, I want this many reads and writes per second allowed on my table. Or you can say, hey, I don't want to think about that all. I want to use on-demand mode, pay-per-use. And what you do is you just issue requests against your database, and DynamoDB is going to track those requests and bill those to you on a per-use basis, just like you would with AWS Lambda or API Gateway, SNS, SQS, S3, any of those things. You're just paying for what you use. use, rather than having to think about that, provision that up front. So that can be really nice for a lot of folks. So when you're setting up your table, you do need to think about that billing configuration and set up those settings. Last thing you need to do when you're creating a table is you need to give your DynamoDB table a name, because that's how you're going to refer to it in your application. So that gets us into our first task here, and your task is going to be create your first DynamoDB table, and here are the conditions I want for you. Number one, give it a table name of users. Number two, set up a simple primary key. It has a hash key of username. And finally, let's set up our billing settings to use provision throughput with read capacity units and write capacity units of 5 for each of those settings. So take some time, get this set up, and then we'll come back and look at how I would do it. All right, everybody, welcome back. Let's see how I'd walk through this task. If you need more time, feel free to pause, but I hope you've really tried this out and look through the documentation to see how you can create a table in DynamoDB given our requirements here. So I'm going to be using an example that I mentioned earlier from that GitHub repo, Alex Debris DynamoDB workshop. So check that out. This example's in Node.js, but you can use any language that's supported by AWS, which there are quite a lot of them, Python, Go, C#, Java, whatever you want to use, it's probably supported by AWS. So let's take a look at our repo here. I have a source directory that has a file called createtable.js. Let's open that one up and see what I'm doing here. First thing I'm doing is just doing some initial setup. So I'm importing the AWS SDK that's allowing me to interact with AWS services. And then from that AWS SDK, I'm creating a DynamoDB client. That's going to allow me to interact with DynamoDB specifically. You can see that I'm passing in a region here. I'm doing region US East 1. You can use whatever region you want, whatever's closest to you or anything like that. So once you have that DynamoDB client, then we're going to call a method on that client to interact with the AWS the DynamoDB service in our region. So that's what we have here, DynamoDB.createTable. And we're just going to pass in an object that has the different configuration properties we want to create our table. And remember, we had 3 requirements for this task. We wanted a table name of users. We wanted to have a simple primary key with a partition key of username, and we wanted to set up provision throughput settings where we had read capacity units and write capacity units of 5 each. So let's walk through how we did this here. First of all, setting up table name of users, super easy. You just pass in a property table name equal to users. Let's set up that primary key, and the way you do that is in this key schema property down here where you pass in an array of objects indicating your primary key there. If you're using a simple primary key, that's just going to have one object in it, your hash key, your partition key, and that's what we have here. You can see this object we have here, which has the attribute name is username, the key type is hash. And setting that up. So that's the key schema. That's how you set up your primary key. But any attribute that you put in that key schema has to be declared in your attribute definitions. So that's what we have up here as well. And the attribute definitions, you're just declaring attributes that actually matter in your table, which again, you don't have to declare most attributes, but if you use them in a primary key, you have to declare them. You have to give them a type as well. So that's what we have here. We have our username. It has an attribute type of S, which stands for string. So a couple different types in DynamoDB that you can use for your primary key. You can use strings, you can use numbers, you can use binary for any of those. Here we're going to be using string for that username. So now we've got our primary key set up. Last thing we want to set up is our billing settings. So we have provision throughput set up. We're going to use read capacity units of 5, write capacity units of 5. Both of those are going to fit within the AWS free tier, which is great. And set that up. So there are all the properties we have for our create table. And then in Node, it uses that callback syntax. So we'll pass in a callback function there where if we get an error back, we'll log that out. Otherwise, we'll say, hey, we got this table created for us. So now that we have this, let's execute that script so we can actually create our table. So I'll do node source create table.js. And you can see our table was created successfully, and we'll go. One thing is, with that that table name, it needs to be unique within your region, so you won't be able to create multiple tables with the same name. So if I run this script again, let's just do that real quick. I can't do that because, this table already exists. There's already a table called users. One last thing I want to mention here before we move on, I'm creating this table with the AWS SDK, and that's for us to learn, but really, usually you're going to want to create this with something like CloudFormation, have infrastructure as code, so you have a codified, repeatable process for creating your infrastructure like this. The reason I didn't do that here is because I think it expands the scope, and now we have to learn about CloudFormation and all the intricacies around that. So I don't want to get deep into that, but I do want you to get familiar with the different things you're going to be setting up. The table name, attribute definitions, key schema, provision throughput. Those are all going to be the same types of properties you'll set up in CloudFormation. So this should look very similar in CloudFormation, but I just didn't want to get into the mechanics of how CloudFormation works. So check that out, in a different video somewhere else. So now that we've created our table, let's move on to the next step. And that next step is going to be focused on loading and reading items from your DynamoDB table. A database is only good if it can actually store that data for you and give it back to you when you need it. So that's what we're going to do here. We're going to load some items into our table, read them back out. We'll start with loading items, right? So writing items into our table. We're going to use the put item operation to do this. So as you're working through this task, look up the documentation around put item to insert that new item into your DynamoDB table. Two things I want to call out here. Number one, when you're using that put item operation, you have to include the primary key on that operation. Remember, you declare the primary key on your table. Every item you write into that table needs to include that primary key, needs to uniquely identify each item in your table. So make sure you have that primary key. The second thing I want to talk about is the DynamoDB object format, because this can seem a little funky, a little interesting to people when they're looking at DynamoDB for the first time. So each attribute value that you write into a DynamoDB item needs to have a type associated with it. We talked about primary key. It can be a string, it can be a number, it can be binary. You can also have attributes that use complex objects like lists or maps or sets. But whatever you write into Dynamo, it needs to have that type associated with it. So you sort of need to annotate these items as you put them in there, and that can be interesting. So let's look at our table that I already had mapped out a little bit, and especially if you look at some of those attributes there. Look at the interest attribute. So interest is an array of different string values. You can see here for Serena Williams, I've indicated that one of her interests is tennis, and you can see it's an object there where the key is going to be the attribute type, so it's going to be S. It's a string type, and the value is going to be the actual attribute value there, so tennis. And when you're writing attributes into your DynamoDB table, you're going to need to annotate them with those type attributes. So S for string, N for number, M for map, different things like that to get it into your table. So make sure you understand that syntax. It can make it a little bit verbose as well, which some people don't like. There is some associated tooling with some of the SDKs. So the JavaScript SDK has something called the DynamoDB document client, where you don't need to annotate with the different types. It just infers it based on the values you pass in there. Python has something similar. So you can take a look at that if you want to, but just make sure you're aware of that DynamoDB object format. So let's get into the task here, and what I want you to do is insert 3 user records into your DynamoDB table using put item. Feel free to look up the documentation around put item and the syntax there, but the mechanics are going to be similar to what we already did with create table. If you want to, I have a few items in that repo, and there's a users.json file that has 3 records that you can put in. They're already in that DynamoDB object format. So if you want to look at the syntax there and see what it is, you can use that. You can just read them from a file and insert them into DynamoDB. But go ahead and take some time, write that put item request into DynamoDB, and pause this and come back when you're ready. All right, everybody, welcome back. Hope you had a good time looking through that put item documentation for DynamoDB. Let's see how to use it here and see how it compares to what you have. I'm going to be looking back in my repo here. Again, in that source directory, I have a file called insertusers.js. Feel free to open that one up now, and we'll see what's going on there. At the top, again, first 2 lines, just a little boilerplate to import the AWS SDK, create that DynamoDB client for the region that I want. And then the next few lines I have here, this is sort of specific to how I have it set up here, but I mentioned I have some users, some sample users in that user.json file, so you can load that up. That's what I'm just doing here, reading that file and parsing it into some users there. And then for each of those users that I have, I'm just going to run the DynamoDB put item operation. So just like we called create table on that DynamoDB client, now we'll be calling put item. It's a pretty simple call here. There are not a lot of properties you got to add in. So you just specify the table name you want to do, which again is that users table we already created. And then you pass in the item that you want. And again, it'll have that callback syntax where you can, if it has an error, you can print that out, or else you can just say, hey, this created successfully. Let's take a quick look at that users.json file just to see, and I have 3 different users in here. Take a note of that DynamoDB item syntax, right? So here's that property. I mentioned you need to have that primary key there. In this case, it's a simple primary key with a partition key of username. We have that here. Notice how we have the attribute name, then we have an object that says the attribute type and the value that we want. And then that's the same for all the different attributes we have. We have an attribute name of name. We have an object. It's a string type of Alex Debris. Interest, is going to be another attribute we have. This is going to be an object where it's a type list. That's going to be an array of different string objects that we have in here. Same thing for address, which is a map type. So this syntax can be verbose, but it makes you be explicit about the attribute types you have. Again, you can use some of those helpers like the DynamoDB document client if you want to. So let's go back and let's execute this file just to insert some of those items into our database. So we're going to have run that node command against that insert users.js file. We'll do that here. And we can see that all of our users were created successfully. So you should have something like this. And now let's check out how to read those items back that we wrote into our table. All right, so reading items from our table, what we're going to do there is use the get item operation. That's going to allow you to retrieve a single item from your DynamoDB table. So let's just move directly onto the task here. The task on this one is read the user items in your table using get item. So go check out the DynamoDB documentation, see what that get item syntax looks like. Remember how important that primary key is. You're going to use that here. That's a little hint. And pause this, and when you're ready, let's take a look at how we do this. All right, welcome back. Hope you had some good luck with that get item operation. Hopefully you're getting a feel for what the DynamoDB documentation is like and how these operations work together. So let's take a look at how I did that. In the source directory, I have a getuser.js file. Let's open that one up. Have this here. At the top, I have some similar stuff to what I've had before, importing that AWS SDK, creating that DynamoDB client. And then on that client, I'm calling the get item operation and passing in the parameters I need. And the parameters on this one are pretty similar, just like they were for put item. You're going to pass in the table name. So here we have a table name of users. And then you're going to pass in the key of the item that you want. Because remember, every item in our table needs that primary key and it uniquely identifies each item. So if we want to go get that particular item, we can do that using the key of that item. So that's what we have here. Again, that's using the DynamoDB object syntax where we're saying, hey, this is the attribute that I'm looking for. It's username, and the value for that is going to be this object where it's a string type with this value of Alex Debris. So we'll pass that in. We have our callback function that prints out the data if we get it back. Let's execute that here and just do node getuser.js. See what we have here. And you can see we've printed out this item. So it says found user, and it just printed out that JSON stringified user that we have here. We can also see what happens, maybe we want to see what happens if that user doesn't exist. And we'll just change it to a different value here, clear that out, and run that again. You can see in this case that user does not exist. So in this case, if you look right here, if there's not data.item, what it means is that request did not return an item back with it. So that item does not exist in your table. So that's how you read items back with DynamoDB. Let's move on to the next step before we close this out here. All right, the last thing we're going to learn before we clean up our table is how to prevent overwrites using something called condition expressions. Let's just remember what we've done so far, right? We have our table, we've written some data into it, and we've seen what that access looks like. We have that put item where we need to have that primary key, insert some other data with it. We also have that get item that acts on that primary key to retrieve that back. So you can really think of DynamoDB in some ways as a key value database, right? Where that primary key is going to be the key for a particular item, and the rest of the item is going to be that value. It's going to pull back the rest of that record with it. The important thing to know here is, every item needs to be uniquely identified by that primary key. So you want to make sure, you're not overwriting something by accident. And, in this case, if I already have a user with the username Alex Debris and someone else tries to sign up with that username, I want to reject that, right? I don't want to have that put item operation succeed if that user already exists. So that's what we're going to see here about how to prevent overrides using something called condition expressions. What condition expressions allow you to do is specify conditions on your write-based operation. So any write-based operation, whether that's put item, update item, delete item, you can have these conditions that are going to get evaluated as part of your request. That condition expression must evaluate to true or the write itself is aborted. So it's going to look at the condition expression before performing that write. If it evaluates to false, it's going to abort that write and cancel it, send it back to you, and let it know that it failed. So let's move into your task here. We want to add a condition expression to our put item request to prevent overwrites, right? If someone adds a new user and that user already exists, we don't want to overwrite that existing record. One hint here is you're going to want to use the attribute not exist function when you're writing data into your table. So again, pause the video, take a few seconds, read the documentation, figure out how to do it, and come back when you're ready to see how it's done. All right, welcome back. Hope you had a good time looking through that condition expression documentation. I know that's a little trickier than the stuff we've done so far, learning this new expression syntax that's native to DynamoDB. But we're going to walk through what this looks like here. I'm not going to go super deep into condition expressions just to keep this sort of short, but I do have another blog post that you can check out on condition expressions. So check that out if you're interested in a little deeper dive beyond that. But again, let's just go back to when we initially wrote items into our table. I'm looking at insert user script. And what we did here is we said, if we insert this data, let's run this script. And run that, and again, it's going to create those 3 users. If I run that script again, it's just going to keep creating those users, and it's not going to tell me, hey, that user already exists. It's just going to override them regardless of what already existed. And that's what we're trying to avoid here with our condition expression. So let's look at this insert users conditional.js, and it's going to be the exact same as our insert user script with this one addition. When we're calling that put item request, we're going to add this condition expression that says attribute not exists username. And basically what that's going to say is if there's an existing item with this same primary key, that username item, don't allow this write to happen. Then it'll evaluate to false and it's going to fail. That's the basics on it. Again, go check out more about condition expressions to know sort of the underlying mechanics of it, but that's the TLDR right there. So let's run this operation again. So node source, let's use our conditional script this time. And what we're going to see is there are errors creating these users, right? We can't create these because the conditional request failed. What happened there is it's saying your condition expression failed, therefore I aborted that write. It didn't happen. So that's what it should look like if you want to use that condition expression. And that's how you make sure you don't override existing items. You can also use it on things like update expressions, right? If you have a bank account and you don't want to allow a balance to go below 0, you can have a condition expression that says, hey, only allow this transaction to happen if that bank account's not going to go, if that balance isn't going to go below 0. So condition expression is really useful for a lot of different things there. All right, that brings us to the last thing I want to cover here today, just cleaning up, deleting our DynamoDB table. You know, we've learned a lot here today. We created our DynamoDB table, we inserted some data into our table, we read it back out, and then we saw how to use condition expressions to prevent writes that we don't want to have happen. Now we're just cleaning it up after ourselves. We're going to delete that DynamoDB table. So that takes us to our last task. Delete the users table that you created. You'll be using the delete table API operation in DynamoDB. So pause the video, take a few seconds, figure that out, and come back when you're ready to see it. All right, welcome back. Hope you figured out how to delete your table successfully. It's the most straightforward operation we've done today, so hopefully you're getting a hang of that DynamoDB documentation. Let's just jump right into it. Go to our source directory and open that delete table.js file. You can see this here. Again, we have that initial setup, importing the AWS SDK, creating that DynamoDB client, and then we're just going to call the delete table method on that client. The only thing you need to pass in there is the table name that you want to delete, and it'll delete your table. Once again, it will delete your table. In this particular case, that's okay, because we have a fake table with a few fake users in it, and that's okay. But if this is a production table, this is going to actually delete your data. So make sure you know what you're doing when you run that delete table operation. That concludes this whole workshop. Hope this was useful to you. Again, we created a table, we inserted data into it, we read it back out, we saw how to use condition expressions to prevent writes we don't want, and then we finally deleted our table at the end. Make sure you check out the other 2 steps in this workshop so you can do composite primary keys and using the query operation to fetch multiple items in a single request. You can also see how to handle additional access patterns with secondary indexes. If you want to see more content like this, go check out my blog, alexdebris.com. You can also check out the DynamoDB book, which is just a comprehensive guide to data modeling with DynamoDB. Otherwise, see you next time.